Howdy, howdy, folks. Once again, this is Donnie, and today we are going to talk about making your secure shell servers even more secure than they already are. Now, Secure Shell, of course, is a great tool for remote server administration because you can sit in the comfort of your own cubicle and from your desktop machine, you can remotely administer servers that are either in your server room on premises or that are running on the cloud, like on a cloud server, like, for example, Microsoft Azure or Vultr or whatever else, right? But anyway, the thing about Secure Shell is that everything goes across the network in an encrypted format. This prevents people from being able to capture your your secure shell traffic and being able to see what you're doing. But the thing is, there are some algorithms that are weaker than others when it comes to encryption. Okay, and also we need to get ready for quantum resistant encryption. And so anyway, I'm going to show you about how to do that today. Now I'm going to show you on non-Red Hat systems. That's because Red Hat has a different way of doing business when it comes to configuring your encryption algorithms. So I'm going to show you here how to do it on non-Red Hat systems, and it should work on pretty much any non-Red Hat uh, Linux distro. Should also work on your BSD distros, Open Indiana, whatever else, right? But as long as they all have that same SSHD config security file or configuration file rather that I'm going to show you, it should work. Now, uh, and also there are several different implementations of Secure Shell. I'm only going to show you how to do this with OpenSSH because it's the one that is the default on pretty much every Linux distro. Also the default on your BSD distros, on Open Indiana, uh, and uh, other distros as well, other operating systems as well. Okay, but anyway, the first thing we're going to do is grab this SSH Audit program and install that on our system. Now, this is not in your distro repositories, so you'll have to log into GitHub and download it from there. Now, if you go into GitHub and do a search for SSH-Audit, you're going to come up with these two entries at the top. This top one is the one that you do not want because you can see it hasn't been updated in the past 9 years. So we're instead going to get this JTesta SSH Audit one, which is still good. Okay, it's still being maintained, and it's actually a fork of that other one that I just showed you. And the guy forked it because he wanted to have a version of this which is in current maintenance. So this is the one you want. All right, now the two ways you can get it, you can click on the code thing up here and you can download the zip file and unzip it to your home directory. Or the way I like to do it is just use Git, and we just copy this URL to the clipboard, and we'll come over here, and you want to make sure to have Git installed on your system using whatever package manager your system uses. And so I'm using OpenMandriva here for my client, so I can just do sudo dnf install git in order to get it. All right, and of course Ubuntu or Debian use apt, and whatever other operating system you're using, just use the package manager for that. And then I'll do git clone, and I will paste my URL in here. And once I hit enter, then it will download the directory with all your SSH-audit files. And of course, I'm not going to do it now because I've already done so. Now, the reason I like using the Git is because once you have that SSH Audit file downloaded to your home directory, you can just cd into it. And then when you want to check for updates, just do git pull like that. And you see everything is already up to date. But if there were updates available, this would get them. Okay, so this is a lot less work than having to go to GitHub all the time to manually check for updates and then manually download the zip file again. But anyway, we can look at our files there. The one that we're really interested in is this SSH Audit.py. And I forgot to mention, this is a Python script. So if we go down here, we'll see the requirements. We need Python 3.8 through 3.13, any one of those versions in that range. And it runs on Linux and Windows. And I haven't tested it on other non-Windows or non-Linux distros, but I would imagine that it'll run just fine on Mac OS or on the BSD distros, as long as you have Python on the machine. It should run just fine. Now, what we're going to do here is I'm going to scan two different machines. I have one machine which is, if I can get to the right window there we go. I have one machine here which is running Ubuntu Server 2410, which is using OpenSSH version 9.7p1, and 2410 is the newest version of Ubuntu Server that's available to me right now. I'm recording this in early April of 2025, so Ubuntu Server 25.04 will not be out for another couple of weeks. And the other machine is Seduction, which is based on or built from the unstable version of Debian, and which is a rolling release version. So it has the latest and greatest OpenSSH 9.9p2. And so the difference is that this 9.9 has a couple of algorithms, newer algorithms, that the old 9.7 does not have, okay? And I would imagine that when Ubuntu 25.04 comes out later this month, it will probably have the 9.9p2 as well. All right, so anyway, let's go now and scan our Seduction machine to see what we got. Really, really easy to use here. Just do like this, and along with the IP address of the machine I want to scan. And you can see it works very, very quickly. And when we scroll back up here, you'll see that, yeah, OpenSSH 9.7 on Ubuntu. Then we have our different groupings of algorithms. Up at the top, we have our key exchange algorithms. We have some in green, some in orange, and some in red. The green ones are the ones that SSH Audit considers to be okay. Orange ones, they're okay, except that they are not quantum resistant. Okay, they're not quantum safe. And so this SNTRUP algorithm is quantum safe. It's been available since OpenSSH 8.5, and it's been the default key exchange algorithm from 9.0 to 9.8. Now, it kind of still is the default. It's just that the 9.9, OpenSSH 9.9 has a newer version of the SNTRUP. But anyway, we'll look at that in a moment. But anyway, this is what's known as a hybrid key exchange algorithm, because this SNTRUP is the actual quantum safe algorithm. This 25519 is not quantum safe. This is the conventional algorithm that that's still in use in a lot of places. But the reason it's a hybrid, the reason they're using the uh, the quantum safe algorithm and the classical algorithm together is because people aren't real trusting of these brand new algorithms yet. So uh, so they so we're using these two algorithms together in a hybrid setup so that in case, let's say that the uh, the key exchange happens successfully with SNTRUP, then it will then go over here to the 25519, and if this key exchange here does not happen successfully, then the key exchange fails. So so both of these two algorithms have to pass the key exchange before the key exchange can happen. And again, this is just in case any vulnerabilities are found in the quantum safe algorithm. Uh, they will be then the key exchange will be blocked by the classical algorithm. All right, and then down here we have some algorithms in red. But look at why they're in red. My goodness. Fail using elliptic curves that are suspected as being backdoored by the U.S. National Security Agency. Oh, yeah. A good old National Security Agency. And they're an interesting organization because it's like they're serving two purposes when it comes to cybersecurity. On the one hand, they want strong cybersecurity for themselves, but they don't want too much cybersecurity for the rest of us, right? And so they have these strong algorithms, but they are suspected as having back doors because they want to be able to spy on everybody, right? And of course, last week I posted a video about the government's war on privacy, and I talked a little bit more about all that in there, so you can look at that video if you want to. But we know for a fact that the NSA has had backdoors and things back in the 90s. They invented what they called the Clipper chip, which they were going to put on email servers. It's going to encrypt everybody's emails going through the network, try to make things more secure. Except it had a backdoor. Okay, fortunately, it did not catch on. Not too many people used it, so it's now dead. And then later on, they created a random number generator algorithm, which actually got put on the list of recommended algorithms, and that the National Institute of Standards and Technology puts out, and uh, an independent researcher did find a backdoor in that. So finally, it got removed from the list of recommended algorithms, right? So anyway, our goal here is to remove anything in orange and anything in red. Anything in orange, non-quantum safe. Anything in red is uh, possible, possibly has backdoors from the NSA. So we want to get rid of them. Then down here we have the host key algorithms, and host keys here, we're in pretty good shape for the most part. Again, we have the red there, which could be backdoored, and the rest of them there are green, and so we're not in too bad a shape there. Then we have the actual encryption algorithms. These algorithms will encrypt the data. They actually perform the encryption of the data, which go back and forth. Okay, so we're setting up a key exchange first. Once we get a key, uh, the key is exchanged, then that's going to provide the key for these encryption algorithms to work. And again, not in too bad a shape there because everything is green there, but we are still going to disable some stuff because we want to uh, also uh, try to come into compliance with the National Security Agency's latest uh, requirements, which aren't in effect yet, but they will be fairly soon. So we're going to basically we're going to get rid of the cha-cha, and we're going to get rid of the AES, any AES that's less than 256 bits. All right, and then of course down here we have the MACs, message authentication algorithms, which which will ensure that nobody has tampered with our communications. And so again, we're going to get rid of everything that's uh, in orange and in red, and we're also going to get rid of the ones that are not on the new list of requirements from the NSA. All right, and then over here, let's go ahead over here, and also, and actually, you know what? I forgot to do something here. Bear with me one moment. And what I'm going to do here is I'm going to add some lines to this. Now I've already added lines here. I just need to comment them out because I forgot to do that before. But anyway, what we're going to do here, in order to disable the algorithms that we do not want, we're going to add all these lines that I'm showing you here, except I just commented them out, of course. And if you want to see the way this part of the SSHD config file looks originally, before I added them, we'll just come over here. And right here, this is what it looks like before I add those new lines. Okay, so anyway, let's go back over here to this machine, and I need to reload my SSH now that I've reconfigured it. There we go. And now let's scan that and see what we got. So now scanning the seduction machine. Okay, so anyway, this looks pretty similar. Of course, up here we got OpenSSH 9.9 now, and up here rather, 9.9 P2 on Debian. And you see there we have a couple new algorithms. We have a newer version of the SMTRUP, which is now the default. It became the default here on OpenSSH 9.9. And we also have the MLK or the MLChem. Okay, and again, this is a hybrid because we want our key exchange to pass on both the MLChem quantum resistant algorithm and the 25519 classical algorithm. And we're doing that just to make sure that the key exchange does not pass if it's found that the MLChem does not work properly. Okay, so we're giving the MLChem a good testing. Now, MLChem was just approved by the National Security Agency just a few months ago, and which is why it is not in our Ubuntu 24.10 virtual machine, and it's also the one that's on the new list of requirements from the NSA. The rest of it looks pretty similar to what we had on the old machine or on the Ubuntu machine. And again, our goal is to get rid of everything in orange and red, and then and also get rid of the green stuff that's not on the new requirements list from the NSA. All right. Now, let me go ahead and show you this new requirements list over here. And the requirements set that we're going by here is called the Commercial National Security Algorithm Suite. Now, right now, version 1.0 is in effect. Version 2.0 is not in effect yet, but they've already published it in order to give people time to go ahead and switch. And if we look here at the timeline or time frame, we can see here that, well, I'm not going to read the whole thing, but the gist of it is that they want everybody to start switching over as soon as possible. They want to start the process by 1 January of 2026, and they and by January 1st, 2027, all new hardware that will be acquired, that will be set up, will be compliant with this new version 2.0. And by December 31st, 2030, all equipment and services that cannot support this new version 2.0 must be phased out. And by December 31st, 2031, the CNSA 2.0 will be used. They will be mandated, okay, unless otherwise noted. Okay, so what are those new algorithms? Well, first we come up here to the chart, and we see AES 256 or better will be the new requirement for our encryption, and I just showed you that on both the Ubuntu and the Seduction virtual machines. We have weaker, we have AES with smaller keys that are enabled, so we will get rid of all the smaller keys. The ML-Chem, which used to be known as Kyber, will be required for our key exchange, and there's also something called dilithium, which can be used for key exchange and also for digital signatures. We don't have that in our OpenSSH, and we will be using SHA 384 or 512 for our signing. Okay. And then down here, these algorithms down here in this lower part, we're not going to worry about them because they're for software and firmware signing. Okay, they have nothing to do with OpenSSH. So anyway, the goal here for now is to configure our both our Ubuntu server and our Seduction server to meet these requirements. Well, actually, we cannot configure the Ubuntu server right now to meet these requirements because it does not have the ML-Chem algorithm. So, but we can still configure it to get rid of all the other algorithms that are not quantum safe. Okay, and so anyway, let's go ahead here and go back over here. And I'm just going to work here with the Seduction machine. And I'm going to open up my SSHD config file. And let's go ahead here. And I set this up all up ahead of time here so that to make things nice and easy. Okay. So the way this works. Okay. First we have the key exchange algorithms. And I have this line twice here. This first one up here that I've just uncommented. It does enable the ML-Chem, and both the old and the new versions of the SNT-RUP. And this is so that we can connect to this from clients that still don't have the ML-Chem. Okay, they are still using older versions of the OpenSSH. and uh, for now that works as long as we have something that's uh, quantum resistant. Now later on, uh, once all your clients, if you have all your clients on the system that are using newer versions of OpenSSH, then you can go ahead and comment that one out and uh, uncomment this one here, which only uses MLChem, and I'll show you that here in just a little bit. Next, the host key algorithms, RSA SHA-2 512. Okay, so we're using SHA 512 for that. Uh, and notice here that the KEX algorithms and the host key algorithms, you list the algorithms that you want to have enabled. Now down here for the ciphers, which are the ciphers actually do the encryption of your data streams, and also for your MACs, your message authentication code algorithms. They're different. Okay, what you do with them is you put a minus sign and then the list of algorithms that you want to disable. I don't know why that they did things like this, but that's the way they did. So anyway, so you see there uh, for the ciphers and the MACs, I've disabled everything that is not on that CNSA list from the National Security Agency. All right. So let's go ahead here and get out of this. And we'll do a reload here to load the new configuration. And oh yeah, also another good thing to do before you do that is to I'm sure it's here someplace. Just do this. Do like that, right? And because right now, okay, see how you have your host machine keys here, and you can do like this, and that will delete all of your host machine keys that are there. And then when you uh, log out of the machine and log in again, it will automatically create new host machine keys that will be compliant with the new requirements. Okay, I'm not going to do that right now, but I'm just telling you this is something that you will want to do in real life. Now, let's go ahead here and scan our new configuration. And yeah, things are looking a lot better here. We have uh, nothing but our quantum resistant algorithms here, which is a good thing. And we've also gotten rid of all the stuff that's not on the uh, new CNSA v2 list. Okay. Down here we have algorithm recommendations, and it's recommending to add those other algorithms back, but as I said, they're not on the newest list of recommendations, the newest set of requirements, so we're just going to leave them off. Okay, so that's a good thing. All right, now let's go ahead here and do something else. Let's log out of here. And we're going to do Wireshark capture. I'm going to show you here that we actually are using our quantum safe algorithms. And so we're going to do a capture here, like so. And then I'm going to come back over here and log back in to my machine. And let's stop our capture. Okay. Okay. By the way, I forgot to mention this is Wireshark, but you probably knew that already. But anyway, let's go ahead and set up a filter here. Filter out everything except for what's going back and forth between that virtual machine. And then I'm going to come back down. I'm going to come down here. I'm looking for key exchange init. And I'm going to look at SSH protocol. You get key exchange. And we see their method SNTRUP, which is what we want to see here, okay? So even though the MLChem is there, and even though the client machine that I'm using, which is OpenMandriva Rome, which is the rolling release version, even though it has the latest and greatest version of OpenSSH, it also includes MLChem. It's still not the default. The TRUP is still the default. Okay. Now we can configure the every client on the network to use MLChem, assuming that the MLChem is available for everything, or we can just reconfigure the server. And again, assuming that MLChem is available on all of your clients. Okay. So now let's go back over here. And we will edit this again. Oops. It would help if I were to go into the correct directory. Alrighty. So let's go ahead now, and we're going to say that, yeah, we've got all of our client machines on the network are compatible with the new standards now. They all have MLChem. And I should mention too that if you have Windows 10 or Windows 11 clients on your network, they, as things stand right now, they do not have MLChem. They are still using, if you're using the if you're using the PowerShell to log in to your servers, they do not have the new version of OpenSSH. They still use the old version of OpenSSH. It does not have MLChem. They do ever have the SNTRUP. So there's that at least, okay? So that's why we might want to leave that line up there. We might want to have this line here enabled instead of this line in order to accommodate, cases like that. Now, if you are on Windows 10 or Windows 11, yeah, there is the Windows subsystem for Linux, which is basically an Ubuntu virtual machine. I haven't tried that, but it probably does not have the MLChem either. It's probably the older version of Ubuntu. And also, there is another way you can use Windows and still have the MLChem, and that's by installing something called Cygwin. All right, so Cygwin is a bash shell for Windows, and you can install Secure Shell on it. It does have the latest and greatest version of Secure Shell, so it will have the MLChem. So you can use it to log into your Linux and BSD servers as well. Okay, but anyway, let's go back over here. And now that I've disabled the SNTRUP algorithms, let's reload, and we'll exit again, and we'll start our Wireshark packet capture again. And we'll log in again and see what we got this time. All right, so go back over here. And I still have my filter enabled, so that's good. So again, let's go up here, look for our key exchange init, algorithms, and you see, yes, indeed, MLChem. Again, that's exactly what we want to see, okay? Now, so that's a good thing. I forgot to mention too, if you are on an older version of Ubuntu or older operating system that does not have the MLChem yet, the configuring of the SSH config file okay, when you configure the SSH config file for them, just leave out the MLChem and the new version of the SNT RUP. So in other words, you'll be making this line it'll look like this, okay? And so at least you'll always be sure of getting the open the quantum safe algorithms there, okay? And even though it's the default, okay? And I should mention that if you are on a client that does not have either one of these algorithms, then you're not going to be able to connect. It won't allow you to connect, okay? So anyway, also while we're at it, actually I'm going to go ahead here and undo all that. There we go. And let's go ahead here and scan it again too. And yeah, so here we got MLChem is the only one we got. And down here it is recommending we add the SNT RUP algorithms in. But again, since they are not on our current requirements list or on the upcoming requirements list, then I'm leaving them out. Okay. And again, I know I keep saying this, but just be sure that all the client machines on your network have the MLChem available before you do this. Okay. All right. So anyway, I think that's pretty much it. In the next video, I'm going to look at how to do this with Red Hat, since they use a completely different method of configuring the algorithms. All right, so that's about it. All right, folks, it's time for a word from my sponsor, which is me. And listen, if you're a Linux administrator or if you're learning how to be one, you want to know how to lock down your Linux servers to be as secure as possible in order to keep the bad guys out. Purchase links are in the video description below, so be sure to click on the link and grab your copy today. You'll be glad that you did.